guys, this is test 44 game 4. This is the parking lot game. I've set up a lot of stuff here, but don't worry, I'm going to explain all of that. Just look at the top diagram for now, where we have Monday through Friday with the parking lots X, Y, and Z, and the costs associated $10, $12, and $15 each. Now on the left here, I've laid out the rules. I'll explain those. First of all, we've got Thursday always being 15, so I'm going to put down 15 right there in the Thursday lot. We know that X is more expensive than Z, so I put X is greater than Z with a dollar sign there to tell us that it refers to money or cost. We also know that Wednesday costs more than Friday, so I've put Wednesday greater than Friday with a dollar sign there as well. And finally, Z is more frequent than X, so I've left out the dollar sign here. And this is simply regarding frequency. Z occurs more frequently than X. So based on this, we can actually infer that there's never going to be two X's in the game. There can only be one X, because if there were two X's, there would have to be three Z's, and the initial rules told us that Anastasia parks in each of the three lots at least once over the course of the week. So I set up two different main diagrams here. Now, how do I do this? I set them up based upon the different cost of Wednesday and Friday, because Wednesday has to be more expensive than Friday. We know that Wednesday can never be only $10 then, because Friday could not then be cheaper than it. So I set up two different diagrams, one where Wednesday is 12 and another where Wednesday is 15. Now, of course, Thursday is always 15, so I'll add that in again. Now, if Wednesday is 12, we know Friday has to be 10 because there is no other cost that would allow Friday to be cheaper than Wednesday, given the three costs are 10, 12, and 15. On the bottom diagram, if Wednesday is 15, then we know Friday could be either 12 or 10. Its cost is undetermined. Now, we can infer a few more things here as well. If X is always more expensive than Z, whenever the cost is 15, we know that Z cannot be the cost of that lot. So on the bottom diagram, we can never have Z in either Wednesday or Thursday, because those days are $15. On the top diagram, where Thursday is $15, we know that Z cannot be $15 on that day. We also know that X could never be $10 because X is more expensive than Z, first rule over here on the left. Now, since Wednesday and Thursday cannot be Z, we know they could be either X or Y, but remember, due to the frequency rule over here on the left, Z is always more frequent than X. If we had two X's, we would have to have three Z's. So we cannot have Wednesday and Thursday both be X in this diagram, because then we'd have to have three Z's, and Y would be left out altogether. So for that reason, we know that on the bottom diagram, we're always going to have Y on Wednesday and Thursday. On the top diagram, things are a little bit more ambiguous. Thursday could be either X or Y. We do not know which one. And then on Friday, it's going to be either Y or Z. So this is pretty much our initial setup for the game. Now, question number 18 is our typical orientation question here. You just want to take one rule at a time and apply that rule to all 5 choices looking for violations. So one thing that's pretty clear is that Z could never be on Thursday. That's an initial inference we've made based upon all the work we've been doing here over the course of the initial setup. So we can scan through the choices looking for Z on Thursday, because that would violate our inference that resulted from the combination of multiple rules. So we scan through, we see that choice E has Z on Thursday. That is unacceptable, so for that reason, E is eliminated for number 18. Next, we can take the rule that X must be more expensive than Z, and we can use that with the combination that Wednesday must always be more expensive than Friday. So we could never have Z on Wednesday and X on Friday. That would be impossible, but choice B contains that, so for that reason, choice B is eliminated. Next, we can take the rule that Z is always more frequent than X, and we find that choice C violates that, having Z and X each twice, not Z occurring more times than X, so C is gone. Next, we can take the rule that we have to, no, so like now you get to A and D, and it might seem like neither of them is clearly violating some rule. Whenever that happens, you should refer back to the initial paragraph of the game where we see that Anastasia has to go to each of X, Y, and Z at least once. So we find that in choice D, there are no Y's at all, which is unacceptable. So D is eliminated, and A is our answer to number 18. Next, number 19, what day can't ever be the $15 lot? So on these two diagrams, of course, we only really have, Wednesday and Thursday appearing to be 15. So for that reason, of course, you can eliminate C and D off the bat. But then it becomes a little bit trickier until you look at Friday, which is the other day about which we know something. So we see that Friday is always either 10 on top or either 10 or 12, never 15. So for that reason, we can infer that E, Friday, is never actually $15. Next, number 20, if lot Z were to be the $12 lot. So if Z were $12, then we could infer that since X is more expensive than Z, according to the second rule of the game, we would know that X had to be $15, which would leave, of course, Y, the remaining lot, to be the one that's only $10. So we see then that the bottom diagram isn't really going to work for us where we have Y being $15. So that diagram is irrelevant. We're only going to look at the top diagram here, and we're going to designate Y to be on Friday, the $10 lot, meaning that Y could not be on Thursday, the $15 lot, so X would have to be on Thursday and be 15, leaving Z to be on Wednesday as the $12 lot. And they're asking us simply, when must Anastasia park in lot Y? And of course that is Friday, we see right here on the top diagram. So E is our answer to number 20. Next, number 21, when can't Anastasia ever park in lot Z? Looking at the main diagram, something we inferred from the very beginning, Z is never on Thursday. You see we've eliminated that as a possibility from the outset. So for that reason, D is our answer to number 21. Next, number 22, what could be an example of a scenario of days in which Anastasia does the $10 lot? So we know she's never doing Wednesday and Thursday. On the top diagram, Wednesday and Thursday are 12 and 15 respectively. On the bottom diagram, they're both 15. So any choice containing Wednesday or Thursday must automatically be eliminated, which gets rid of D and E. So now the question is, of course, they're not even mentioning Friday. Could we have both Monday and Tuesday? Let's see if we can have either of those at all. So you could easily imagine on the bottom diagram, we've got the $10 lot as Monday and Tuesday, of course, because we're not using the top one where 10 was on Friday. That's not even in any of the choices. So could we have 10, 10, 15, 15, 12? Could that ever work? No reason to think it couldn't. Works perfectly fine. Maybe we could have, let's say Z be our $10 lot, of course, to allow X to be our $12 lot so that X is more expensive than Z. That works out perfectly fine. We're complying with everything. So for that reason, choice C, Monday and Tuesday, works and is our answer, number 22.